Tesla, a company that has shown electric cars can have much better ergonomics, and also that going electric gives us more quirks and features as compared to the traditional gasoline-powered cars. Not only this, the company is working on something called FSD, or Full Self-Driving. And after public release of FSD, they are expecting to launch Robotaxi, which is a self-driving taxi or driverless taxi. We are discussing everything about Tesla's Robotaxi and its potential to disrupt the road transportation industry in today's video of Discover Zen. Tesla, currently the most valuable car brand in the world, is really working in a very different direction out of all the other companies out there. They even announced a new in-house produced battery for its electric cars, signaling a major shift from the automaker that, if successful, could significantly reduce the cost of electric vehicles. Tesla's new battery cell features a tabless design, which the company claims will provide 5 times the energy, 6 times the power, and 16% more range compared to its old battery cell. Not only this, the company is even testing the full self-driving beta feature on their cars. Now let's talk about Autopilot and FSD, or Full Self-Driving, in detail. Autopilot is an advanced driver assistance system developed by Tesla. Tesla states that Autopilot is designed to assist drivers with the most burdensome parts of driving in order to make Tesla cars safer and more capable over time. As of now, Tesla Autopilot features require active driver supervision and do not make the vehicle autonomous, as the full self-driving feature is still in beta. Starting in September 2014, all Tesla cars are shipped with sensors and software to support Autopilot. Initially, hardware version 1 or HW1. Tesla upgraded its sensors and software in October 2016, HW2, to support full self-driving in the future. HW2 includes 8 cameras, 12 ultrasonic sensors, and forward-facing radar. HW 2.5 was released in mid-2017, and it upgraded HW2 with a second graphics process unit, GPU, and, for the Model 3 only, a driver-facing camera. In early 2019, Tesla released HW3, and all of its cars will include Autopilot software, defined as just traffic-aware cruise control and auto steer, which is in beta, as a standard feature moving forward. Full self-driving software, which includes Autopark, Navigate on Autopilot, which is in beta, Auto Lane Change, which is in beta, Summon, which is in beta, Smart Summon, which is in beta, and Future Abilities is an extra cost option. On April 24th, 2020, Tesla released a software update to Autopilot. With this update, cars recognize and automatically stop at stop signs. The car also automatically slows down and eventually stop at traffic lights, even if they are green. The driver will indicate that it is safe to proceed through the traffic light. Full self-driving is an optional upcoming extension of Autopilot to enable fully autonomous driving. At the end of 2016, Tesla expected to demonstrate full autonomy by the end of 2017. The first beta version of the software was released on October 22, 2020, to a small group of testers. The release of beta FSD was renewed concern regarding whether the technology is ready for testing on public roads. Tesla's approach to achieving full autonomy is different from that of any other company. Waymo, Cruise, and other companies that are relying on LiDAR, highly detailed centimeter scale, 3-dimensional maps and cameras, as well as radar and ultrasonic sensors in their autonomous vehicles. Tesla's approach is to use coarse-grained 2-dimensional maps and cameras in addition to radar and ultrasonic sensors. Tesla claims that although its approach is much more difficult, it will ultimately be more useful because its vehicles will be able to self-drive without geofencing concerns. Tesla's self-driving software has also been trained based on 3 billion miles driven by Tesla vehicles as of April 2020. In terms of computing hardware, Tesla designed a self-driving computer chip that has been installed in its cars since March 2019. Most experts believe that Tesla's approach of trying to achieve full self-driving by eschewing LiDAR and high-definition maps is not feasible. In a March 2020 study by the Navigant Research, Tesla was ranked last for both strategy and execution in autonomous driving sector. But when it comes to real-world autonomous tests, Tesla blows everything else out of the water. FSD Beta, presented in October, has already demonstrated clear success and is able to drive a car for a long time, even in challenging road sections without driver intervention. In parallel with this, Tesla Autopilot has shown many times its excellence in avoiding accidents in the most difficult situations, anticipating collisions that have not yet occurred. Now let's talk about one of the most ambitious goals of the company: Tesla as a robotaxi fleet. Robotaxi, also known as self-driving taxi, is said to be the autonomous car operated for any ride-sharing company. The main condition for this to be feasible is when the SAE autonomous level reaches 4 or 5. Tesla's autopilot technology is currently at level 2, also known as partial automation. The vehicle can autonomously perform some functions, including steering, acceleration, and braking, but Tesla requires all drivers to maintain control of the vehicle while on autopilot. Please note that we have not considered FSD Beta for this result. If we look at FSD Beta results, we could say that Tesla has broken into level 3 autonomy and is still improving. Tesla CEO Elon Musk said that he is confident that all Tesla vehicles will achieve full autonomy in 2021. He is even confident in assuming that, in 20 years, all cars produced will be electric vehicles with fully autonomous driving. However, Musk reckons that 70 to 80% of cars will be autonomous within about 10 years. So, what is SAE autonomous level? SAE International, previously known as the Society of Automotive Engineers, is a US-based globally active professional association and standards developing organization for engineering professionals in various industries. In SAE's automation level definitions, driving mode means a type of driving scenario with characteristic dynamic driving task requirements. Example given: expressway merging, high-speed cruising, low-speed traffic jam, etc. There are 6 levels of autonomy. Level 0. The automated system issues warnings and may momentarily intervene, but has no sustained vehicle control. Level 1. Hands-on. The driver and the automated system share control of the vehicle. Examples are system where the driver controls steering and the automated system controls engine power to maintain a set speed, cruise control, or engine and brake power to maintain and vary the speed, adaptive cruise control or ACC, and parking assistance where steering is automated while speed is under manual control. The driver must be ready to retake full control at any time. An automatic emergency braking that alerts the driver to a crash and permits full braking capacity is also a level 1 feature according to the Autopilot Review magazine. Level 2. Hands off. The automated system takes full control of the vehicle, accelerating, braking, and steering. The driver must monitor the vehicle and be prepared to intervene immediately at any time if the automated system fails to respond properly. The shorthand, hands off, isn't meant to be taken literally. Contact between the hand and wheel is often mandatory during SAE2 driving to confirm that the driver is ready to intervene. Level 3. Eyes off. The driver can safely turn their attention away from the driving task. Example given: the driver can text or watch a movie. The vehicle will handle situations that call for immediate responses like emergency braking. The driver must still be prepared to intervene within some limited time, specifically by the manufacturer when called upon the vehicle to do so. You can think of the automated system as a co-driver that will alert you in orderly fashion when it is your turn to drive. An example would be a car satisfying the International Automated Lane Keeping System (ALKS) regulations. Level 4. Mind off. No driver attention is ever required for safety, i.e., the driver may safely go to sleep or leave the driver's seat. However, self-driving is supported only in a limited spatial area, geofenced or under special circumstances. Outside of these areas or circumstances, the vehicle must be able to safely abort the trip. Example given: slow down and park the car. If the driver does not retake control, an example would be a robotic taxi or a robotic delivery service that covers selected locations in an area at a specific time and quantities. Level 5. Steering wheel optional. No human intervention is required whatsoever. An example would be in a robotic vehicle that works on all kinds of surfaces, all over the world, all year round, and all weather conditions. Now let's assume that Tesla achieved full autonomy and released robotaxi service. How would it work? Tesla aims to roll out a smartphone app, similar to Uber, where users can hail a ride from Teslas in the area. Vehicle owners can specify a time of day where they want their car to join the network, enabling them to be used when the owner doesn't need it. The owners of those cars can then earn money from the trips. The passengers could take the rides on robotaxis at a much lower cost than its non-autonomous alternatives. Since it doesn't need drivers, the car owners will be able to profit even while providing taxis at such lower prices. This could lead to enough funds to pay off the value of the car over the space of a few years. Analysis from ARK Invest suggested an autonomous car could earn its owner $10,000 per year once running costs are removed from the equation. This model makes it a win-win situation for Tesla, their car owners, as well as the passengers. So this is all about Tesla's FSD and robotaxi in detail. Now let's see, how is Tesla making an exciting future for humanity? Well, actually, that sounds like something to discuss on the next episode of Discover Zen.